Welcome to our latest explainer. Look around. It's pretty undeniable that our reality is literally being rewritten by digital data right before our eyes. But today, we're going to cut through all that code and focus on the physical side of this massive evolution. We're talking about the actual architects of our new reality, how industrial robots are actively building our tomorrow. Now, it's super easy to look at a sleek drone swarm or some massive robotic arm assembling a car and just feel, well, awe, right? But let's pivot that energy for a second. Instead of just admiring that cool futuristic surface, I want us to ask the really foundational question here. But have you ever wondered how they actually work? We see the magic all the time, but we rarely see the mechanics. So today, we're stripping away the outer shell to take a deep, analytical look inside.
All right, here's our blueprint for today's explainer. First up, the future is here. Then the hands building tomorrow, followed by decoding the digital brain. After that, we've got the electronic nervous system, real engineering, and finally, decode the future. Let's dive right in.
Section 1. The future is here. A world transformed. So zooming out, our world is essentially built on 5 absolutely crucial pillars: artificial intelligence, robotics, embedded systems, cybersecurity, and semiconductors. And the thing is, these aren't just isolated lab experiments anymore. No way. They are the synchronized engines actively constructing smart cities and pushing space tech forward right now. But, all this brilliant digital theory, it actually requires real physical labor. Which brings us to Section 2, the hands building tomorrow, robotics in action. Think about it like this. If AI is the architect, these robots are the hands doing the heavy lifting. Stripping away the casing on these industrial builders reveals an absolute masterpiece of mechanical engineering. You've got this heavy, stabilized chassis forming the base, intricate joints that provide the articulation, and these incredibly precise servos actually driving the movement. It's like a beautifully choreographed dance of metal and motors, all working with sub-millimeter precision. But here's the kicker. The scope of these physical hands is expanding so fast. The robotic workforce goes way beyond those stationary arms just bolted to an assembly line. We're talking autonomous drone swarms mapping out our environments, advanced humanoids navigating massive warehouses, and quadruped robots, those dog-like ones, traversing crazy rough terrain. They're physically interacting with our world in ways that, let's be honest, were pure science fiction just 10 years ago. Now, let's jump into Section 3, decoding the digital brain, AI and semiconductors. Because, obviously, metal and servos can't build a single thing without intelligence, right? That software intelligence comes straight from neural networks. Imagine a really massive, intricate web where data is continuously flowing, kind of like energy pulses. It's crunching complex math to process insane amounts of sensory information in real time. This right here is the digital brain that dictates the exact actions a robot needs to take. But that software needs a physical home, doesn't it? If we zoom way past the heavy chassis, right inside a pristine clean room, a simple silicon wafer gets etched into a CPU die. And this die houses literally billions of microscopic transistors. A lot of them are actually smaller than a biological virus, and they're firing electric pulses at the speed of light. This glowing microscopic grid, that is the literal physical brain of our industrial builder. All right, moving on to Section 4, the electronic nervous system, embedded systems. So the big question is, how does that microscopic brain actually talk to those massive mechanical hands? Well, you need a bridge. Embedded microcontrollers, things like the ESP32, the STM32, Arduino boards, and Raspberry Pis, they act as that central nervous system. These printed circuit boards sit right at the crossroads of software and hardware. They act as digital translators, turning all that abstract math and complex AI logic into the actual physical electrical voltages that tell a massive servo motor to move, say, exactly 2 degrees to the left. To truly wrap your head around this nervous system, you've got to get down to the bare electronics. You can't just write code, you have to visualize the raw electricity. I'm talking about hooking up oscilloscopes to read signal waves, maybe burning a little flux while you're soldering PCBs, and wiring up logic through breadboards. Honestly, this raw electric pulse is exactly what breathes life into the machine. Now, scale that embedded logic up to process heavy AI tasks, and boom, you get a full computer architecture. If you look at it, you can basically trace the digital signals traveling across the motherboard. The CPU acts kind of like the traffic cop. The GPU crunches that really intense neural network math. The RAM holds all the short-term memory, and the SSD stores the core parameters. Every single piece has to operate in perfect harmony to drive tomorrow's robotics. Which leads us nicely into Section 5, Real Engineering, More Than Theory.
You know, it is wonderful to look at slick diagrams, but let's be real. Passively absorbing theory on a screen or just binge-watching typical tech channels, that is not going to build the future. True engineering requires stepping off the sidelines. It actually requires wrestling with the concepts, breaking things, running test simulators, and just pushing through until the mechanics finally click in your head.
And that means getting your hands dirty with practical applications. Literally building robots, designing your own PCBs, and iterating custom parts with 3D printers. Oh, and as these robotic networks grow more capable, understanding ethical hacking becomes absolutely paramount. Because securing these industrial systems, activating firewalls, and setting up digital locks, that is just as critical as building them in the first place. Finally, we arrive at Section 6, Decode the Future. Join the community. Once you understand the hands, the brain, and the nervous system, you really start to see where this whole convergence is taking us. By mastering these foundational layers today, engineers are currently pushing into some incredible territories. We're talking autonomous flying vehicles, deeply integrated smart cities, the mind-bending math of quantum computing, brain-computer interfaces, and space technology destined for other planets. And industrial robots are out there laying the infrastructure for all of it. But here is the absolutely crucial reality we have to remember. Building this future isn't done in a vacuum. It requires a global, connected network of human minds. It takes a digital community, students, engineers, and creators, all sharing their open-source projects, asking the hard questions, and collaborating across borders. It all boils down to this one core philosophy. The people who understand it today will build tomorrow. Taking the time to learn the electronics, the AI, the coding, and the robotics right now, that isn't just picking up a fun hobby. You are literally forging the tools required to shape the future of humanity. You've seen the blueprint, you've looked inside the machines, the technology is out there just waiting to be mastered. So the real question I want to leave you with is, are you ready to decode the future, join the community, and start building tomorrow? Keep learning, keep building, and I will see you in our next explainer.